right, this video is looking at just section 12.5. Okay. They suggested we look at page 720, questions 23 through 26. So we'll go ahead and look at maybe just two of these, let me go ahead and look at the even ones. You can do the odd ones yourself. All right. So we're looking for the area under the normal curve. Right here in the middle would be the mean. If z is a positive number, you go to the right. If it's a negative number, you go to the left. And these numbers here represent z-scores. It's like one standard deviation above the mean, 2 or 3, 1 below, 2 below, 3 below. I'm looking at 24. So a z of negative 1.09 would be a little past negative 1, and a z of negative 1.56 would be a little past halfway there, and they want us to get the area between those two, and it says percentage of the total area. Okay, so we want that right there. So what you're going to do is go to your z-score table to get the a value for each of those. So we don't have negative values in the table, but that's okay because of the symmetry of the normal curve. So we're going to go look at 1.09 and get the a value associated with that. 1.09, that would be 0.362. Let me write that down. That would be 0.362. And negative 1.56. Negative 1.56. We don't have negatives. We just go to 1.56 and we get 0.441. 0.441. All right. So the 0.441, all the stuff you get out of the table represents the percentage of data values from your z-score. So like this one here was the negative 1.56, from that to the mean. So like all of this would be the green one. Okay. And then from negative 1.09 to the mean, so that would be this right here, just to the middle. That would be from that z-score, negative 1.09 to the mean. So what I want is this little amount in between those two, and they're on the same side of the mean. So the purple from negative 1.09 to the mean would be 36.2%. So the purple would be 36.2%. Okay, and then the green would be from negative 1.56 to the mean. So the green would be 44.1%. And I want that little area that's green, but you take away that purple spot. Like you want just the spot in between. So it's a subtraction situation. So I want to take the 44.1 and subtract the 36.2 from it. Okay. And so I'm going to get 7.9%. And that represents just this little strip right here. In between those two would be 7.9%. Okay. All right, let's draw a picture for 26. Okay, mean is 0, then 1, 2, 3 above, 1, 2, 3 below. So 1, 2, and 3. Negative 1, negative 2, negative 3. And this is the mean, or a z-score of 0. Okay, 0.98 would be just shy of 1 on the positive side. Negative 1.42 would be on the negative side. Okay, and I want this area between the two. See how they're on different sides of the mean? So I'm going to go to my table. So if z equals 1.42 and if z equals 0.98, what are the a values, the areas under the curve? So let's go to 0.98 and you get 0.336, 0.336. And if the z is 1.42, I get 0.422. 0.422. Okay, so this part right here, so this information is telling me from the mean to that z-score. So this green part would be 42.2%. Okay, then this information tells me what's happening there. So that is the 33.6%. See how they're on opposite sides of the mean? I need the total area between the two. I would add, and that would be 75.8% all total. Okay, that would be my final answer. All right, and then one more would be one maybe in context. So on this one, okay, so it says the peaches were normally distributed. The mean was 14. Standard deviation was 0.6. And then the sample of 1,000 peaches. And it tells us to take a look at 31 to 36. So let me move that information a little closer to those problems. So we know the mean was 14 ounces and the standard deviation was 0.6 and the number of peaches was 1,000. So keep that in mind. We'll have an extra step on these. Okay. So let's do a couple of these. Let's do more than something. Let's do between. Let's do maybe 34 and then maybe 35. And you can do the rest. I'm just picking a few that have some different things happening. Okay, so all right. So let's think about 31. So on 31, the mean would be at 14. All right. The standard deviation was 0.6 and the amount I'm doing is 12 and I don't have z-scores. So I'm going to go ahead and find the z associated with 12. So I'm going to take 12 minus 14. So 12 minus my mean and divide by 0.6. So 12 minus the 14, hit enter. So that's -2. Divide by 0.6 because that was your standard deviation. And your z-score there turns out to be about a -3.33. Round to 2 decimal places because that's what your z-table does. Okay. All right, now I want more than 12. So -3.33 means I'm out here. Okay. And let me change it to a different color so you can see. So like here, out past the third standard deviation line, out here. And then I want to be more than that. So that means not just stopping there, but all of that. So what I'm going to get out of my table is just going to be from here to the mean. So whatever that is, I'll add 50%. So I'll get what I need to, and then I'll add 50% is my plan. More than 12 ounces. So I need to go and look at 3.33 in that z-score table. I'm going to go back here. 3.33. It's basically 0.5. Okay. So this is a weird one. So it turns out to be an A value. The Z value was this. Okay. And the A value associated with that was 0.500 or 50%. So basically 100% of the data should be 100% of the peaches should be more than 12 ounces. And there's 1,000 of them. So you'd expect all of them to be more than 12 ounces. Okay. Let's try another one that's kind of like that before we do 34. At least 14 ounces. So 14 ounces. Well, that's a special one because 14 was the mean. So at least 14 means 14 or more. That should be 50% of the peaches, and there's 1,000 of them. So that would be 0.50 times 1,000. That would be 500. Okay. All right. Let's go ahead and look at 34. 34 says between 14 and 15.2. 1, 2, 3 above. So we don't know 14's right at a standard deviation of 0, standard deviation line of 0. It's the mean, so it's right in the middle. So I need to first take my 15.2 minus the mean divided by the standard deviation. So 15.2 take away 14 gives me 1.2. Divide by 0.6, and I wind up getting exactly 2. So it says determine the number of peaches between 14 ounces, and I know I'd be right here when I'm at 15.2. I need to find that. And what I'm going to do then is look at, so this is a Z of 2. I'm going to get the A value associated with a Z of 2. So I go here, I go to 2 and get 0.477. A Z value of 2 is 0.477. Okay, 0.477. So that is telling me that this green area would be 47.7% of the peaches. And there's 1,000 of them. So I'm going to take 0.477 times 1,000, and I get 477 peaches. Okay, for my final answer on that one. All right, let's do one more. Let's look at 35. So this is 35's picture. Okay, 14 is there. 1, 2, 3 above. We already know that the standard deviation is 0.6, and I already found that that was 15.2. This was 14.6. This would be 15.8. So I'm going to be at 15.5, so somewhere in there. And 14.9 is a little above 1. So this would be a z-score of 0, 1, 2, 3. And I want to look at from a z-score, something that's a little bit past 1, and then over to there. So I need the z-scores. So I'm going to do 14.9 minus 14 divided by 0.6. I get 0.9 over 0.6. That's 1.5. And then 15.5 minus 14 divided by 0.6. That's going to be 1.5 divided by 0.6. That's going to be 15 divided by 6. I'm simplifying that. That's going to be 5 divided by 3. 5 halves, so that would be 2.5. So we're talking about between 1.5 and 2.5, this right here. Notice they're on the same side, okay? So those are Z values right there, okay? So I need the A for each of those. So the A value for 1.5 is 4.433, 0.433, and the A value for 2.5, let's go back to the chart, look at 2.5, 0.494, 0.494, 0.494, okay? So now I'm looking at how the 0.494 represents all the way from that value to the mean, and then the 0.433 represents just this part, and I want what's in between those two right here. Okay, so I'm going to be subtracting. I'm going to take 49.4 minus 43.3%, both of those percents, and 49.4 minus 43.3 gives me, I didn't type that in right, 49.4 minus 43.3 gives me just 6.1%. So this right here would be 6.1%. Notice they're on the same side, right? They're both over on the same side of the mean. So I'm going to be subtracting, and I'll get 6.1% of the peaches, and there's 1,000 of them. So I got to remember to do that extra piece and multiply 6.1%. That's 0.061, right? 0.061, and then multiply by 1,000. So I'd get 61 peaches. Okay.